Our brain is made up of billions of neurons and they are connected to each other by junctions known as synapses. In order to talk to each other, our brain uses electrical signals that travels down to the axon and reaches the synapses, and thereby they form action potentials. And these action potentials can lead to vesicle release or neurotransmitter release in the synaptic cleft. Here action potential, which is flowing down the nerve terminal, is causing vesicle release in the synaptic cleft. But how this action potential can cause vesicle release is the question. So synaptic vesicles filled up with neurotransmitter are just like a ship trying to dock to the port. And when the ship comes closer to the port, it would throw its anchor and thereby it can dock. Similarly, our neurotransmitter vesicles have anchor-like things known as snare proteins, and these snares are vesicle-bound snares. And other side, the target membrane or the synaptic active zone membrane has target snares or T snares, and this T snare and V snare interaction can allow the vesicle fusion of the neurotransmitter vesicles. If we zoom into the details of this neurotransmitter vesicle fusion, we would see there are proteins like synaptotagmin, synaptobrevin, which is helping to sense the action potential and allowing the snare interaction, the vesicle snare and the target membrane snare interaction. There are other proteins like cysteine string proteins, MUNC18 and syntaxin, which are stabilizing the snare interactions. Now, when action potential flows down to uh, the axon, there is calcium increase, and the calcium increase is sensed by a protein like synaptotagmin, which has calcium sensing domains like C2 domains, and thereby it can allow conformational change and converting loose snare complex to a tight snare complex, and thereby ultimately bringing the two membrane of the vesicle and the target membrane so closer that they can fuse to each other and thereby releasing the neurotransmitters. And once the neurotransmitter is released, the T snare and V snare interaction is resolved by proteins like NSF. They have protease activity which can cleave off the interaction and thereby recycling a new round of T snare into the system. And if I talk about the vesicle release, there are multiple type of synaptic vesicles. Some are readily releasable, like which are docked to the membrane and just waiting for a signal to release. There are recycling pools and there are reserve pool which are not released frequently. So about this kind of vesicle pools I would be talking into my next video. Hope this video helped you, and thanks for watching. Please subscribe, like and share. Thank you.